In today's lesson, let's start up with these warm-up questions. So you're converting the name into a chemical formula. So remember that Roman numerals are indicating the charge that you need to use. So our iron should be a 2+ iron. Oxygen has a charge of -2. So when you crisscross your charges, this now is going to become iron 2 oxide, but without the 2. In the second example here, they are asking us to use the multivalent iron 3 with oxygen. So this time we are using iron 3+ with oxygen. Remember to crisscross your charges. So I should have iron and oxygen with the 3. The IV, remember, represents 4. So this is lead, 4. And sulfide, which has a charge of -2. So crisscross the charges. And then in this case, because they both can be divided by 2, you're going to reduce your charges. So that should be our answer there. Over here, we want to convert the chemical the chemical formulas into a specific chemical name. So for example, if you're looking at nickel, you should be looking at the multiple valence that nickel would have. So nickel has either 2 or 3. So doing a little bit of thinking, the 2 is coming from the oxygen, so the 3 must have been coming from the nickel. So that means in this example, it's a nickel 3 oxide. Here we have cobalt. So cobalt is either a +2 or a +3. So again, you're going to do a little bit of thinking. The sulfur had the 2, so the 3 must have come from the cobalt. So this is cobalt 3 sulfide. Here we have copper and oxygen. So oxygen should have a -2 charge. So because that -2 is not written over here as a subscript, that means the copper and the oxygen would have been reduced. So this should have been a copper +2. And lastly, so we know that oxygen again has a charge of -2. Your lead has possible 2 or 4 charges. So you have to think, well, if the oxygen got reduced, this must have been a +4 in order to change into a 2 and reduce. So this is a lead 4 oxide. So in today's lesson, we are looking at something called polyatomic ionic compounds. We're going to do chemical formulas, and we're also going to name them. So first of all, what is a polyatomic ion? Polyatomic ions are groups of atoms that tend to stay together and carry an overall charge. So they are a group of atoms. They are found on the front of your periodic table. So if you notice your periodic table here, these are some of the polyatomic ions that we could be using. So the formulas and the names are given to you. The charges are in the top right corner there. So you'll notice that the bottom numbers are telling you that they have a specific number of those atoms. So this is why we say that there are groups of atoms with an overall charge. So for example, your nitrate has a charge of -1 on your table, and your phosphate has a charge of -3 on your table. So compounds that contain polyatomic ions, here are various number of polyatomic ions in some of our compounds. So we could see them in chalk, in building material, in stomach antacid to neutralize stomach acid, in our car batteries, bleach, fungicide, laundry detergent, and fertilizer. But your polyatomic ions are also very important in preservatives. So anytime you have a preservative, chances are they do have some sort of polyatomic ion in them. So they're pretty versatile in terms of where they're found. So as I mentioned, these are the polyatomic ions that are on your chart. So they will react with another ion. So you can see that most of them are negative. Pretty much all of them are negative except ammonia. So ammonia is actually a positive, a cation. So we're going to make sure that we're writing that ion first. Your polyatomic ions will always keep its name. So this is always going to be true. We never ever change the name. So that's why they're always going to be given to you. You're just writing the names that are found on this chart. So let's try combining sodium with carbonate. So you know sodium is Na and it has a charge of +1. Your carbonate, so notice that it doesn't end in a normal ending that we've seen before. So anytime you see an ATE or an ITE, you're going to look at your periodic table. So I'm going to look up carbonate on my chart there. So over here, you could see that carbonate has a C, a 3 oxygens, and a -2 charge. So I'm going to rewrite that here. So when we combine them, you follow the same rules. Your charges need to crisscross and come down over here. So I should see the sodium with the 2 and the carbonate, because I have a 1 there and we don't write the 1s, then I can ignore that 1 and just write whatever I have. So now I have CO3. So that's the chemical formula. In terms of the name for this compound, we just combine the names. I don't change the name for my polyatomic. So this is called sodium carbonate. Your polyatomic ions can form multiple oxyanions. So what that means is you can find various number of oxygens. So if you have one more oxygen, it's going to have an ATE ending. So looking at, let's say, chlorate and chlorite. So this is our normal polyatomic ion with an ATE ending. Anytime you have an ITE ending, it means you have one less oxygen. So notice in my chemical formula, everything stays the same except I have one less oxygen. So here's another example with nitrate and nitrite. So nitrate has NO3 -1 and your nitrite has NO2, so one less oxygen. So you don't have to memorize those. Those are going to be found on your periodic table. So here's another one, phosphate and phosphite and sulfate and sulfite. So here are just specific examples outlining them for you. So again, the ITE has one less oxygen. So one less oxygen. ITE has one less oxygen. Here are some other types of polyatomic ions that we're going to be using. Ammonium, like I mentioned before, it's the positive ion. Every other polyatomic ion that we have is going to have a negative charge. So these are all -1 charges here. So hydroxide, bicarbonate, acetate, these are just some other common polyatomic ions. So let's try and name the following if we have the chemical formula. So remember, you're still going to look at the cation part and the anion part. So I could clearly see that I have a magnesium. And because this is a group of atoms connected together, I'm going to look on my chart and find PO4. So the PO4 is going to be phosphate. So we don't change the name, we keep the name. So it's called magnesium phosphate. here we have clearly Cu is copper. Okay, and we have SO4. So using your periodic table, SO4 is a sulfate. So we have copper sulfate. The only problem is, remember that copper is a multivalent. So copper can be a +1 or a +2. Your sulfate has a -2 charge. So if that -2, or if that 2 does not come over, or it looks like it's been reduced, that means the copper must have been the +2 here. So it's a copper 2 sulfate. And like I mentioned before, if you don't know which one it is, you should be trying both of them. So if I did copper 1 and sulfate, okay, my formula would be, if you crisscross them, Cu2SO4. But if you had the copper +2 and the sulfate, when you crisscross those charges, those will reduce and you're left with copper sulfate. So this is the one that matches this specific formula there. So it's a copper 2 sulfate. So last slide here, let's try and write the chemical formula and the name for each of them. So calcium means that we have Ca, and you should find its charge, +2. Notice an ATE ending. So I'm going to look on my chart here. Carbonate is CO3 -2. So when you crisscross those charges, because they're both 2, they will reduce. So calcium and CO3 is what's left. So in terms of a name, this is called calcium carbonate. The next example is ammonium and oxygen. Ammonium is not on our periodic table, so you're going to look here and look up ammonium, which is NH4 +1. And oxygen, which has a -2. So when you bring this down here, they're not going to reduce, okay? So the 2 is going to come down over here, and the 1 is going to come down over here. So we don't write 1s, but you also can't have 2 numbers beside each other. So you're going to notice now that we're going to use brackets. So the NH4 is still there. You don't reduce those subscripts, okay? So NH4 is always NH4. That stays together as a group. But now that charge is telling me that I have 2 of those groups there, and the oxygen. So remember that we don't write the 1. So the name for this one is ammonium oxide. So notice this time, because it's an oxygen, it's not a polyatomic, I need to change the ending to oxide. Lastly here, I have lead 2. And I have a phosphate. So that ATE ending, I'm going to check on my periodic table. So at the top of my periodic table, I'm going to see phosphate, PO4 -3. Your charges are going to come across. So I should have a 3 here and a 2 here. I cannot have 2 numbers beside each other. So again, I'm going to need to make sure that I'm using brackets. So the 3 is there, but now the PO4 stays as a group, and I need to put the 2 outside. I cannot do this. Okay, so this is incorrect. You have to use brackets to separate the number of them. So the name for this is lead 2 phosphate.